Positive reinforcement coaching. Positive reinforcement coaching is when the instructional leader observes a classroom for the express purpose of identifying a talent. What does this teacher have a special knack for? What does he or she do particularly well? Whenever we're trying to identify talents, it's often good to look for when the teacher receives a curveball, right? When things go a little bit off script. That's when we see teachers revert back to their natural talents in the classroom. One of the instructional leader's jobs is to be able to identify these talents and label them. Mental models, performance feedback, chunking. This allows us to go to the teacher in a positive reinforcement coaching session and say, first of all, way to go. You made some excellent instructional decisions today, and they resulted in excellent learning for your students. But that's not enough. We also want to be able to say to the teacher, not just way to go, but here's why it worked. This is what it's called. Here's the science behind it. Let's brainstorm some ways we can have you do this again and again and again, not just today, as you did so well, but in future classroom sessions as well. Sherry Whitlock, thank you very much for joining us today. You are a middle school math teacher.
Yes, I am.
7th grade specifically, right?
That's right.
Great.
Thank
Congratulations on that.
Thank you.
We were just talking a moment ago. You've had a chance to do a little international travel. That's been fun, hasn't it? Have you ever had a chance to visit some of the schools in any of the places that you've been?
I haven't. Actually, yes, I have. Went in, I forgot about this one a while ago. It was in Washington. You had to go on a 5-hour boat ride to this remote area. It's called Stehekin. And I got to see a little one-room schoolhouse, kindergarten through about 8th grade, and then they would send their children into Seattle. But that was so interesting. Their chores, instead of collect the papers or whatever, bring in the wood. They had a wood-burning fireplace. Just, you know, it was just, I felt like I was in pioneer times.
That's right.
It was really
Instead
neat.
of dusting the erasers, go out and bring in the wood.
It was really fun.
Oh, that's great.
Yeah.
Well, thank you very much again for participating. What we're going to do today is called a positive reinforcement coaching session. And let me outline that a little bit for you. What basically it is I was in your classroom observing, and I have some notes here on the observation. I'd like to share with you some of the findings. And although you did, you know, dozens of things that helped kids learn math that day, I want to zero in on just one episode of teaching that was really effective and talk about that a little bit. And so part of the conference was just me saying, Sherry, way to go. This was an excellent moment of teaching in American education. And the second thing will be, let's look at that and learn a little bit about why it worked so well. And so that's why it's called positive reinforcement. It's sort of catching you in the act of being brilliant and saying, now let's deconstruct that and what was going on at that time. Does that sound okay?
Sounds great.
All right, good. So one of the things that I noticed is that when you were teaching, very often, instead of just telling students something, you were asking them to predict. You were saying, well, what do you think the answer will be? Or which one do you think will be greater? Or which one do you think will finish first? And it takes longer to do that, but you seemed like you felt like it was important to, instead of just giving them the information, to have them predict why or who will win or which will be greater or less than. Talk a little bit about why you do that.
Okay. Well, we had just finished our geometry section on the 2D geometry, learning all, you know, geometry has so many formulas.
Right.
And so they were learning about area of rectangles, circles, and triangles. So I wanted to connect that. We were going into the 3-dimensional shapes, wanted to connect that. And I don't know about you, but when I was back in middle school, the teacher said, okay, here are the formulas. Do this one for the cylinder, here for the prism, you know, and it was very stressful, to be honest with you, and I remembered it for the test.
Right, me too.
And then I probably forgot it. And it didn't really make a connection until I started teaching this unit, and I wanted to make it real for the kids so they would remember why that formula worked, not just, oh, well, I'm going to do this and plug in these numbers. I want it to make sense.
You're thinking there's got to be a reason for this other than just memorizing the formulas.
Right.
That's exactly right. That is the effect that it had. Let me share with you some of the notes that I took. When I was in your classroom, I took a few notes on you and followed you around and said, this is what you're doing. I took some notes on the students and what their work was like. In a perfect world, there's a nice connection between what the teacher does and what the students do, and in your classroom there was. And then I took some notes on the environment, a little bit of your classroom sketch and some of the descriptors of the social, emotional environment and the physical environment. The one thing that I'd like to point out, and again, there were just several great instances of instruction, but in coaching, I've always found it's better to just pick one. So I want to zero in on where you did this activity where you had them take a triangular, what's that called?
Prism.
A triangular prism, and then
Oh, I'm sorry, that was the pyramid. We took the prism
the
first.
prism first,
we
and then the pyramid.
Compared it to the pyramid.
And you then took a rectangular prism and compared it to a rectangular pyramid, and then you took a cylinder, and what you did was you said, I want you to predict how many, what will the volume be like? And you actually had these little things where you could fill them up with water and pour, so you could prove it.
Right.
But instead of just saying, look, the volume of a cylinder is always 3 times the volume of a cone that has the same base, you didn't tell them that. You made them predict it. You said, what do you think? And a lot of them said 2 times. Some of them said that it'll be the same. A few of them got it right. I was sort of interested that most of them underestimated,
Well,
that it
did
was
you
like
see
that.
DJ's face? He said, well, can we really do it?
Right.
And then we said, well, yeah,
And he was playing right into your hands.
Oh, yeah, he
Not only
loved it.
can we, but I've
And
got
he
a
will
plan
remember
for
it,
you.
too. He'll remember it.
Whenever you ask students to predict something before you prove it to them, that really helps enrich their memory and their learning. That right there is an excellent instructional decision. Taking the time to predict before I prove.
Right.
One of the things we know about gifted readers and how they're different than typical readers isn't that they read faster necessarily. The reason they tend to understand and recall more is they're always predicting. So I'm reading the first chapter, predicting what the second chapter will be like. I'm reading about the main character and predicting what will happen to her later on. And it doesn't matter how accurate their predictions are, it's just the fact that they're predicting and then proving, predicting and then proving. And that's just such a good example of that. That really helped kids remember that concept. So just like you, they'll probably grow up and say, no, I don't have any trouble remembering those formulas, I hope, because my 7th grade math teacher taught it to me in that way. So that's the way to go part.
Okay.
That really helped. That really helped them remember. Now let's talk about kind of the name for that, how that works. There is a name in learning theory for what you just did, and the name of this principle of learning is called mental models. There are different types of mental models. The mental model that you used so well today is called an intuitive intellectual mental model. Now, I like to think of predict and prove. Predict is the intuitive part. It's your intuition. It's your gut instinct. It's what do you think the answer will be. Intellectual is the prove part. Now, I know this is a little bit of an oversimplification, but if you just imagined a student and their brain, all brains have a left and a right hemisphere. The left hemisphere of the brain is the part of the brain that students like to prove things. That's where our intellectual processing happens. So let's say you didn't. Let's say you taught them that just exactly the same way you were taught. Memorize the formulas. That would have been all those chunks going into the left hemisphere without anything really in the right hemisphere to correspond. But no, you didn't do that. You said, before you learn the formula, let's predict how many of these will it take to fill this up. Now, prediction, intuition, is a right hemisphere function. So if there was like an MRI or a PET scanner on every one of your students' brains while you were teaching that lesson, their whole brain would have been active. And that's what leads to such enhanced recall and transfer later on. They're really learning it in multiple regions of their brain. Does that make sense?
It's a good thing.
It is a
Very
good thing. I know when I was in school, I had some really great teachers, but sometimes they fell in love with just one methodology. My 7th grade math teacher fell in love with the overhead projector. right? So she used, the only variation we got was really green ink and blue ink. And I'm not sure which one, but all of my algebra goes into this one part of my brain, left hemisphere. What you're doing is saying, now, before you memorize the formula, I want you to predict how that will be. That just helps them remember it so much better. So that's the science behind that. It's don't just teach it, have them first predict, that's intuitive, and then have them prove, that's intellectual. Let's jump into the future a little bit. What are some things coming up in your math curriculum where you could continue to apply this principle of learning? Predict it and prove it instead of just learn it and memorize it.
I actually think that's going to be rather easy. We're getting into probability. That's our next chapter. And I was thinking, well, what I would like to do is give them 2 dice, roll the dice. Well, ask them first, predict which number you think will come up the most when you add the 2. There really is theory to that, but I want them to experiment with it first. And we could use the dice, or we have some really neat calculators that have probability simulation on them. Which, for me, it's nice because you can get a whole lot more data they can hit. All right, I'm going to roll the dice 100 times, and it does it so quickly. They're going to love it because it's like a handheld game, like a little Game Boy or whatever.
That'll connect.
And we can get a huge amount of data in a little bit of time and then connect the experiment with the actual theory.
So instead of just teaching whatever the formula is of predicting the probability of rolling a 7, let's say, with a pair of dice, they'll actually do a prediction first. What do you think? What is the probability? Is the probability of rolling a 7 the same as the probability of rolling a 2? Which it's not, is it?
No,
I think I remember that, yeah. But at first glance, you think, well, yeah, it's all the same. I have equal. So they predict, and then they prove. When they're predicting, they're learning in their right hemisphere. When they're proving, they're learning in their left hemisphere. Gosh, that's a good idea. What else? Probability.
Well, throughout the year, we've been working on measurement. Measurement is a weak strand, I think, for most kids. And so we've been working on measurement. So I'd like to tie in metric and the customary system.
Okay.
So maybe do predict, okay, if you walked 5 kilometers or 4 miles, which one do you think you would have walked the farthest? And why? And we could
predict it first, then prove it, calculate it out, see which one is it, by the way, do you know? You got to tell me.
Miles.
It is. 4 miles is longer than 5 kilometers. Again, when they predict, right hemisphere, when they prove. So probability, measurement, such a good job today in. This is something, Sherry, that I think you have a knack for. Often what we do when we coach is we look for talents. And a talent often is something that maybe doesn't seem that special to you because you use it all the time. It's kind of I couldn't think of teaching any other way. And just watching you teach, you tend to just go back to this talent again and again. Don't give them the information. Make them guess. What's your intuition? What's your hunch? And you make it safe for that. You don't say, okay, I'm not counting it. You can't get this wrong. All I'm asking for is a prediction. And then let's go back and compare. That is an excellent principle of learning. It's called mental models. Now, what I'd like to do, if it's all right with you, is as we've identified this kind of a knack or talent that you have, I'd like to continue to work with you on this. And so I have some information I might put in your mailbox, a couple of video clips that are kind of interesting. There are also lots of other types of mental models in addition to the predict and prove type mental models that I think you'd find interesting as well. Would that be okay?
I appreciate that, yes. Very much.
Give me a little feedback then on the coaching session. What we're working on is helping folks like me get better and better at giving teachers feedback that's constructive and positive in addition to being evaluated. So I wanted this to feel like a conversation between 2 colleagues, and I didn't want it to feel like you were being judged or evaluated or this is going to go in your personnel file. Give me a little feedback on that. How did that feel?
Well, I want to let you know how valuable and helpful and encouraging it is when you hear a strength. When you build on someone's strength. That's what we do to our students. You do 3 pluses and a wish. I really like the way you did this. Now let's build on this. When a teacher, we're human too, when we hear that, we know we're doing something strong
Exactly.
and something successful, then we're more open to work on something and either build on that strength or
Right.
try some other
And both
strategy.
are good strategies. I'd say first to build on, because when we're strong in an area, like you're strong in this idea of predicting and improving, what we really know is you've got some good room for improvement there because you're already, talented in that area. A great singer has more room for improvement than I do, even though you might not think that's true because I don't have much talent in that area. Well, that's good. It was a pleasure to be in your classroom,
Thank you.
and I look forward to working with you again. And congratulations on the great job you did with mental models, and especially the intuitive intellectual type.
Thank you, and thank you for your feedback.
You're welcome. Thanks.